In this video, we're talking about subtraction. So whole numbers, decimal form, fraction form, how to do subtraction. Remember, subtraction is taking away or finding the difference, or converting it into an addition question. So just like with the addition, the question becomes, what can be taken from what? Or how do you describe the difference? So again, let's talk about context. So 5 minus 1 equals 4. 5 chairs minus 1 chair equals 4 chairs. 5 minus 1 equals 25. On the surface, doesn't appear to be true, but give it some context. 5 dimes minus 1/4 equals 25 cents. The context is called the unit. And just like with addition, we want to subtract like things. So we want them to have the same unit is the easiest way to understand and do subtraction. So we can change the unit without changing the value of the number. Let's go back to that 5 minus 1. 5 dimes minus 1/4. I make that 50 cents minus 25 cents. And there's my 25 cents. So without changing the value of 5 dimes, I just changed the unit. 5 dimes is 50 cents. 1/4 is the same as 25 cents. I just changed the unit. Now I have cents and cents. 50 cents minus 25 cents gives me 25 cents. So if there is no context, and this is going to happen a lot, when we're subtracting numbers in decimal form, then the unit is related to the place value. So 763 is really 700 plus 60 plus 3, which is the same as 700s plus 6 tens plus 3 ones. So if we want to subtract 763 minus 21, that's 700, 6 tens, 3 ones, minus 2 tens and 1 1. And now we're going to combine units. So we take the 700, there's only one of those, there's no subtracting hundreds, so we're going to leave that. We take the 6 tens minus 2 tens, there's my 4 tens. I take 3 ones, I subtract 1 1, and now I have 2 ones. So I have 700, 4 tens, and 2 ones. So this should say 742. Without writing out all the digits. So just like with addition, I like the idea of columns. Columns is something that you do even in the traditional algorithm, but it's a nice way to organize those numbers. So in the last example, we'll do it again. It had hundreds, tens, and ones. So there's my 763, 700, 6 tens, 3 ones, and then I'm subtracting 2 tens and a 1 1. So I just go ahead and do that. So I take 3 ones, I subtract 1 1, I have 2. I take 6 tens, I subtract 2 tens, I have 4. 700s, I'm not subtracting anything, so that stays as 700s. Columns are also very helpful for borrowing. Just like with addition, columns were helpful with carrying. Columns are going to be very helpful for borrowing. So borrowing happens in a situation like this. So now I have 1,937 and I'm subtracting 854. So I'm going to set up my columns. I need a thousands this time because it went that big. So I have thousands, hundreds, tens, ones. So there's my 1937 and then I'm subtracting 854. So I start at the ones place, I take 7 and I subtract 4 and there are my 3 ones. Then I move to my tens place. I have 3 tens subtract 5 tens. I don't have enough. I don't have enough tens the way this is written to subtract 5 of them. So I need to borrow. I need to grab those from the hundreds. So I'm going to come over here and I'm going to say, hey, you have a whole lot of hundreds. Let me have one of those. Let me borrow one of those. Let me break that $100 bill down into $10 bills. So I'm going to take 100 from the 900s and I'm going to break it into 10 tens. So what happens is now instead of 9 tens, instead of 900s, I have 800s. And now instead of 3 tens, I'm adding 10 more tens. So there's my 13 tens. And now I can do the subtraction. So I take the 5 from the 13 tens. So I have 13 minus 5, that leaves me with 8. And then I keep going as usual. 800s minus 800s, 1,000 minus nothing, leaves me with 1,083. So 1,937 minus 854 is 1,083. Where's the mistake here? Now notice the mistake is not in lining up the place values. They did a good job of that. They have the tenths all lined up. The 3 is in the tenths place. The 1 is in the tenths place. That 2 is in the tenths place. Right? They line up their place values nicely, but they did something else. If you look at the hundredths place, so come over here. They lined it up properly, but we're supposed to be subtracting 4. We're taking away 4. But instead, the 4 just stayed right where it was. It didn't actually take away 4. And this is where the columns can be helpful. So anytime you have a column that doesn't match the top and the bottom, then fill in whatever number is supposed to be there. What number is supposed to go right here? Well, if there's nothing written there, it's a 0. So put the 0. So columns, thinking of this as columns, then it might be easier for us to see, oh, there's my 0. So now I have 0 hundredths, and now I need to take away 4 hundredths. In order to do that, I need to borrow. So I don't have any hundredths in the 65 and 30 hundredths. So I need to borrow. I'm going to borrow from the 3, and I'm going to borrow by remembering that 1/10 is equivalent to 10 hundredths. So I'm going to take 1/10 from that 3, so now I have 2, and then I'm going to bring 10 of those over to my hundredths place. I didn't have any there, so I just have 10. Once I've made that borrow, now I can subtract. 10 minus 4 is 6. 2 minus 1 is 1. 5 minus 2 is 3. 6 minus 0 is 6. So just by thinking of each of those place values as a column and filling in that 0 that was missing in the original setup of the equation, then I can see that I need to borrow to get those hundredths taken away. So what about fractions? Again, please don't memorize rules. Memorizing can lead to all sorts of issues. You memorize one little thing wrong and you'll never be able to fix it. So it's important that you don't just memorize, go for understanding. It might take longer. It might take longer to do each question, and that's fine. In fact, that's great. Understanding is better. So for example, 4/7 minus 2/7. Again, the way we read it tells us what the unit is. This is 4/7 minus 2/7. We already have the same unit. So 4/7 minus 2/7 is 2/7. A little bit more challenging if they have different units. So here's 2/5 minus 1/3. Fifths and thirds are not the same unit, so let's draw and make them the same. So the orange is my 2/5. I took the whole rectangle, I broke it into 5 parts, shaded 2. The blue is my 1/3. I took the entire rectangle, broke it into 3 equal parts, and shaded 1 of them. Now, it's hard to see the difference between these two numbers or to subtract these two numbers as in taking away in the way that they are. We need to make them the same unit. So it was split in fifths going in the vertical direction and thirds going in the horizontal direction. So I kept that for both. So I have fifths, thirds, which gives me 15ths. So now in the orange, I have 6/15, and in the blue, I have 5/15. So now I've created the same unit. If I think of this as taking away, then I'm going to take 5 blocks away from the orange. Right? I have 1, 2, 3, 4, 5 over here. So if I'm going to take them away, 1, 2, 3, 4, 5, and I'm left with 1. This is the only one I have left over. So I have 1 piece when there are 15 in the whole. So there's my 1/15. Or using the same pictures, if I think of subtraction as difference, what's the difference between the orange and the blue? Well, the orange has 1, 2, 3, 4, 5, 6 pieces. The blue has 1, 2, 3, 4, 5. So to cover the same area, I just need one more block. So one more of those little rectangles with 15 in the hole represents 1/15. If we think of subtraction as addition, we would be asking, what do I need to add to the blue to make it the same size as the orange? So again, what I need to add is I need to add one more shaded block. So that's one rectangle, 15 in the hole. So you're starting to hopefully see that these three different interpretations of subtraction really obviously lead to the same answer, but even conceptually they lead to some of the very similar ideas to each other. But they're distinct and they're different enough that it's sometimes helpful to use one over another. Okay, so what about mixed numbers? Mixed numbers are exactly the same. We did this with addition, right? You just draw out whole boxes and then break up a box to represent the fractional part. The only time that mixed numbers become a little bit different is if we have to borrow. So we're going to do an example with borrowing. So here I have 2.5 minus 1 2/3. So in green, I drew out my 2.5. And then in blue, I drew out my 1 2/3. So just like before, it's hard to compare these without having the same size pieces. So I went ahead and broke the half and the 2/3 into sixths. So it was broken in half in the vertical direction, thirds in the halves in the horizontal direction, thirds in the vertical direction. If I do that to both squares, I end up with 6. So now I've rewritten this equation to be 2 3/6 minus 1 4/6. So this is exactly what we would do with addition. This is exactly what we do if we don't need to borrow. So hopefully now we see the problem. If I'm trying to take away 4 of these little boxes, I don't have 4 to take away. I only have 1, 2, 3. I need another one of those little boxes. So what am I going to do? I'm going to break that hole into little boxes. So that's my borrowing. Although in my picture, I'm not borrowing anything. I'm just taking a hole and breaking it up into sixths. Why sixths? Well, the other ones were broken into sixths, so let's keep it sixths. Now if I want to think of this as taking away, technically looking at the picture, I have 1 9/6 in my green, and I have 1 4/6 in my blue. Or visually, I want to take these away, so I'm going to take away this 1, so that's taking away this. I'm going to take away these 4 little ones, that's 1, 2, 3, 4. So what do I have left? What I have left is 1, 2, 3, 4, 5 of the small blocks. 5 blocks, when there are 6 in a hole, gives me 5/6. Or drawings are also nice for as difference or as addition. In other words, what else would I need to make the blue and the green shape be the same? Well, what I would need is I would need to color in this square and this square and this one and this one and this one. And if I colored in those squares, then the area of the blue with the purple would be the same as the area of the green. So what did I color? I colored 1, 2, 3, 4, 5 of those little squares when there are 6 in a hole, so that's 5/6. So I need 5 little boxes, 5/6. Summary. When subtracting, it is helpful to only subtract digits that have the same unit. In the decimal world, the place value determines the unit. If you need to borrow, then take something from the place value larger, take one of those items, and turn it into a bunch of the smaller items. In fractions, the size of the piece determines the unit, assuming the holes are the same, which we do unless they tell us otherwise. So it's the number of pieces in the hole, or ultimately the denominator, that determines the unit. Important. Do not do any step of borrowing without thinking. You shouldn't do any step of any problem without thinking, but this in particular. Think about what is happening when you borrow. You take one from a column or from a whole. What is happening when you bring it to the next one? Stay away from, oh, cross it out, draw one. Cross it out, draw one. That's what we get in the habit of doing, and we don't think about what the borrowing is. So examples, when I take 110, that becomes 10 ones. If I take 1,000, that becomes 10 hundreds. If I take 1/10, that becomes 10 hundredths. Think about that as you're doing it, and you definitely have to think about it with fractions. 1 whole becomes 5/5, or 9/9, or 2 halves, or 3/3, or 17 seventeenths, or 42 42, etc., etc. You have to think about that borrow.